Please like, subscribe and share. Your likes and shares can help us take Atheneum and Northeast to the world. Subscribe to our YouTube channel and stay connected on Facebook for regular content.
Hello and welcome at Atheneum. Today we have with us Dr. Brinda Bhowmick. Dr. Bhowmick is an Associate Professor of Electronics and Communication, Department of Engineering, National Institute of India, Silchar, Assam. Her research interests include simulation and modeling of semiconductor devices like TFET, FINFET, and their application as sensors. Dr. Bhowmick has published one patent on system, method, and apparatus for generating true random number for identification and verification. She is the co-investigator of CSIR EMR 2 project and has achieved the Visvesvaraya Young Faculty Research Fellowship by Ministry of Electronics and Information Technology, Government of India in 2018. On behalf of Atheneum, I cordially welcome you to today's discussion on research and innovation in STEM in the Northeast India. Welcome, Dr. Brinda.
Thank you, Dr. Nandini, and thank you for providing me and giving me an opportunity to talk about my research and innovation in the recent electronics and communication engineering.
Right. So Dr. Brinda, just to introduce you to Atheneum, Atheneum has a diverse set of audience, right? And for everyone to understand about what you've done and about your research and innovation. I have seen your Google Scholar profile, and with the limited understanding that I have on STEM, I see that you are working in the area of microelectronics, which is so fascinating. Would you please elaborate a little bit on it?
I am working in the field of microelectronics. So actually, what is electronics? We can say electronics is nothing but a subject related to physics and technology, where we can study the flow of electron in vacuum tubes, in semiconductors, and in conductors. So microelectronics is also related to electronics. It is part of electronics, where we can design microchips. Microchips means as we are coming across various new technology nodes, we are reducing the device dimensions. As for example, I can say you about mobile. Okay. We want to reduce the technology node so that we integrate many devices in a single chip. That is why we are reducing the technology node dimensions. Now we are in the technology node of 7 nanometer. That is why we are reducing the device dimensions, and we are working in the nanometer range, even less than micrometer. Okay, so that is why my research is based on the reduction in technology nodes, where we can apply various semiconductor devices in reduced technology node, where say the length of the device may be in 10 nanometer or maybe in 20 nanometer, like that we are working. So the microelectronics is nothing but the design of microchips, and as we are moving towards recent technology nodes, we are reducing the dimensions still further.
Okay. So would you please, tell us, for our audience also, what is the difference between electronics and microelectronics?
Electronics is a broad subject where we can study some high power devices also, as well as low power devices also, which can apply it in high power. High power say are electrical circuits, where we are discussing about power distribution and all. These are related to high power. But my research area is related to low power, and microelectronics is just particularly related to design of microchips, where the device dimensions are in the range of micrometers. That is the big difference between the two.
Dr. Bhowmick, in our daily lives, there is the application of electronics all over, isn't it? And which is, of course, very,
Yes,
very
everyone
intriguing.
is application of electronics. Nowadays, people are making smart homes, smart
Yeah, yeah.
cities, and smart building. So nowadays, this electronics even though earlier also you have seen refrigerator, then our mobile application, the computer, then we have the different laptops. Cheap of the laptop, you can see various transistors are there. So my work is basically based on the design of those different types of transistors are there, and we are designing different types of transistors so that whenever we reduce the dimensions, the power dissipation of the devices should be very negligible. And another factor is the cost. Obviously, whenever we want to buy anything, say a mobile, for a laptop, we will always consider the cost. So we are try to design a device that will provide us less cost, and obviously it should be economic, and the power dissipation of the system should be lesser.
Right. So, on that note, actually, this was the second part of my question, that for newbies like us, who do not really have much knowledge on electronics, are not directly related to the subject, would you please, tell me which part of your research exactly is directly applicable to the common man?
The common man means we are nowadays, my research area is dependent on device and application of the devices in sensors also. Now I am designing a sensor, that biosensor. So what we are doing, we can, nowadays COVID-19 has come. So my students recently, they want to detect the COVID-19 virus, because with the help of those devices, what they are doing in the whatever device I am telling, these are all transistors. So my device is tunnel field effect transistor. So in that device, what we want to do, we want to apply the tunnel fed device as a biosense, so that we can detect various biomolecules and we can detect various diseases with the help of, and simulation in the lab using various software analysis we are doing. And till now, it has not been implemented in a experiment, you can say. So simulation results we have checked, and we have checked that the tunnel field effect transistor can be a future biosensor for detection of various diseases. Okay, we can detect pH level of the blood also, and we can detect some viruses also. And for that, COVID-19, we need one parameter, that is high K data, that is a dielectric constant. So till now, people have not determined the dielectric constant of COVID-19. That is why what we are doing, we are considering different proteins, and different proteins may have the dielectric constant near to the COVID-19 virus. So that is why what we are doing, we are replacing the by a particular protein which has the same dielectric constant as, maybe, but we are not sure because still research is going on. So it may have that dielectric constant value equal, and by considering those values, we are trying to implement the various biosensors. So that research I am doing recently, just 1 year. We are doing after after the COVID, when there is COVID pandemic situation. So myself and my student, that Vandana Devi and Rupam Goswami, they are related with this work.
Okay, brilliant, brilliant. That is so, fascinating to hear. So now my next question in the line is that, now coming to your entry in the field of STEM, and let me, just go back and start with your BTech days. How difficult, was it for a girl to navigate a highly male-dominated space?
Yes, it is there, but in NIT Silchar, you can say the environment is quite good. Because when we have studied in 1997, I took admission in NIT Silchar. At that time, it was REC Silchar, Regional Engineering College there. At that time, we were 48 students in electrical engineering. So out of 48, 8 girls were there. And I at that time, whenever, since we are 8 girls, so I have not faced that much problem at that time. It was almost okay. Sometimes I feel that in while doing some experiments and we have some carpentry lab also in first year. Then at the time we faced very carpentry lab, then welding workshops are also there. At the time I faced some problem, but have helped our teachers and my batchmates also. They have helped us, and no, I have not faced that much problem, I can say.
Okay, so now that brings me to my second question in the line, and it is, why do you think that there are fewer women in STEM? And the reason why I'm saying this is that I teach social sciences, that, and there was a student who said that women, they are genetically made for literature and not for science and technology. Now, of course, I mean, there is absolutely, I feel there is no, relation to it. But what is your idea on why do you think that, there are so few women in STEM, since you're saying that in 48, there were just 8 girls? So, yeah. Is it because
actually, what I can say that nowadays, actually, in earlier days, women are not giving that much opportunity. And they are not, say, in a house, one son and one daughter was there. So people want that my son will study and daughter, whatever she is doing, that is okay. But in India, actually, we think that girls are only made for marriage, and after marriage they will cook and they will do all the household work. Like that, our mind is like that. But nowadays it has been quite, it is changing, and our government has also provided various schemes where we have to show, and sometimes when we are going for NBA accreditation, National Board of Accreditation by the central government, when we need that one, we need that one for every NITs. So they have kept a provision that male to female ratio. That is why always we give preferences to the female students also, and we are encouraging them. So why do you study? Why don't you learn? Sometimes female students, they are saying that we will not go for higher studies. So we are encouraging those female students that you should go for higher studies. Why don't you go for MS in outside India? Why don't you do PhD? Like that, we are trying to encourage. And our institute is always encouraging female students as well as female faculty members also. In our department, recently there are 30 faculty members, and out of 30, 7 are lady faculties. So this is very good, because nowadays I have seen in electronics and communication only has a large number of female to male ratio as compared to other departments.
Right. So you're saying that things have improved. Okay. So now I move on to my next question, and I just wanted to know that what made you choose academia over the industry, which seems to be more lucrative?
Yeah, industry. When I was a student, when I was a final year student, I was a final year student in the year of 2001. At that time, what happened? Few companies I was also interested to join IT industry. My friends were in Wipro, in Satyam Computers. But at that time, what happened? Very few companies came, and I did not get job in final year campus recruitment. Then after that, I decide that if I do higher study, then it may be a better opportunity. Then it may bring some better opportunity for me. Then I appeared GATE and I did my higher studies. And after that, I thought, then whenever I was doing my PG study, at that time I was assigned some teaching loads. So whenever I started teaching the students, I liked that profession. And I thought that it is very interesting. Whenever I teach some student, I can also learn, and they will also learn from me. So teacher-student attachment was very good. It seems to be very good, and if I choose this area as my future profession, then it will. I thought that then I can teach my student, then I can learn, then I can do some research also. That is why I came to this academia.
Okay. Also, do you think, because you stayed back in Assam, so do you think staying back in the region put you in any kind of disadvantageous position as compared to your peers in the same field who are probably now residing in the out of the region?
One of the disadvantages, say, when you want to buy some experimental setup, okay, some laboratory equipments, so these are not available in our locality. Okay, we have to order them from faraway places, from Delhi, from Calcutta, and some electronic equipments we need. So we cannot get this thing very easily. It will take some time, because our students are also want to do some new projects, so they want to buy some new pens and components. Then they have to wait for some time. And during the COVID situation, they have faced a lot of problems, because many students are outside NIT Silchar, and it is very the difficulty is that we are far away from the middle part of the India. And sometimes also training and placement department is also facing some problem, because some companies, they don't want to come to Assam. Even it is Silchar is far away from Guwahati. So sometimes some companies are coming to the Guwahati, and they are calling our students from here also. So these type of problems we are facing. But nowadays, as the railway has, broad gauge has come to Silchar, that provides us a better opportunity. Because of that, our students can go outside, and they can also do some work, and they can do some summer internship. And our institute has made various moves with universities of USA. So some students are going during the summer vacation and winter vacation. They are going outside India, and they are some project, and they are coming again back to the institute.
Right. So one more thing, since you're saying that, students, there is an exchange program also. But
Yes.
why do you think that students should stay back in the region in the domain of STEM and also in general? So what are the, probable prospects and challenges?
Yeah, here in this area, since we don't have any industry, okay, so we can provide small projects for the improvement of our locality. Okay, I can say that we have tea gardens. So various tea processing units are there. In electronics industry, we can develop some tea processing units. Since nowadays tea gardens are lagging behind. Okay, so what we can do, we can provide them some new machines, new controlling tree. We are extracting tree from the tea leaves, so that those extracting machines can be made. And recently, Silchar is facing Silchar to Shillong, that road, we are facing problem due to landslides. So we can do some work on that area also, because nowadays we are working in interdisciplinary area. So civil engineering is taking care of that landslide, and electronics and computer science, what they can do, they can develop some software to help to diagnose those problems. Okay, so now and another problem here, wheat. There are lots of diseases are there related to wheat production, and rice diseases are there. Those diseases we can identify, and we can rectify using different algorithms. So this works we can do for the locality.
Right. So again, it brings me to my question on what is the scope of research in electronics in the region. So, and this is absolutely Northeast specific. Yeah.
So the Northeast specific, you can say in Northeast, as there are no opportunity for big industry. We do not have any big industry. So that is why people are not absorbed. Here, local people, wherever they are, say after BTech, after graduation, most of the engineers, they are going outside, near south, or some of the people are going outside India also. They are going because there are no IT industries, and even public sectors are also there. Okay, that BHEL, and we have DRDO, Defense Research and Development Organization, ISRO. There no center is available inside the Northeast region. That is why what we can say, suggest them that the students, those absorb, they can go outside. And some of the students, those who are interested in research, in the innovative research area, they can do some research work for the development of our Northeastern people. They can develop various schemes so that our local people can learn various softwares. They can for example, I have told you about the tea processing units, about the locality. They can work for these type of projects, and they can do work in solar energy also, because solar energy is an energy which can be easily extracted and can be useful, so that we can save our electrical energy, whatever energy is available. So like that, this type of work we can do. Already we are doing in our institute. We have lots of solar cells where we can power our street lights are there. Those street lights were powered by the solar cells. So this is the project made by our colleagues. And one of my colleagues is also doing a project, Spark project, the USA also. So like that, people are doing collaborative work, because so that our Northeast people should be get some facility. Whatever facility is available, that facility should be gained by the local people of our state, or you can say Northeast people.
That is so brilliant. And I just wanted to know a little bit more on the current research that you are doing. You said that there is some sort of circuit that you're designing for. Could you please elaborate a little bit more on that? So what happens is that
actually my basic work is related to simulation. I already told you, tunnel field effect transistor simulation we are doing. Various structures we are designing so that we can reduce the dimension and we can save the power. Now my patent, whatever patent which I have published with my students, in patent it is applicable for security. Okay, how we can say it? I can explain it. Whenever a person say entering in a say restricted area, so you are two units are available. One is image capturing unit. Another circuit is available with us. So image capturing unit, what it is doing, it is collecting the data from the images, and it is storing in a PC, okay, or a computer, or maybe a laptop. And another circuit is available which will provide you some random numbers. So that circuit consisting of LED and light dependent resistors and infrared photodetector. Okay, so this circuit is generating true random number, and the image capturing unit is also providing us some data. So whenever a person is entering, what we are doing, we are mixing up the image capturing data with the circuit. So this data together we are keeping in a system. Now next time when the person is again entering, then what we are doing, again we are matching whether the person has entered, whether it is matching with the existing data available in our database. So if it is matching, then the person is allowed to enter in that place. So like that, we can generate a security system. So that a place where you say in a room, you want to enter only 10 people, or in an army based camp, you are allowing only 100 army men in that area. So what we can do, we can give them we can take their images and we can generate the security identification code for each of them. And whenever they are entering in that area, we are checking whether the person is same or not. If they are same, then only they are allowed to enter. Otherwise, they are not allowed. So like that, we have posed a security system by that patent work. Yes.
So that is about your patent. I also wanted to know about the, about the new, current research that you're doing on COVID-19.
Yeah.
You said, I just wanted
COVID-19. COVID-19 is what is that I am telling. The thing is very interesting. So what I have seen people have already made biosensors, because whenever we are considering a new work, we are studying various literatures. We are doing the literature survey. So what I have seen, people has made some biosensor based on they are detecting some biomolecules. Okay, biomolecules based on some proteins and etc. So detecting. Now we have thought that how we can do it. So what we can do it in the whatever device we have. Actually, I think you are a non-engineering student, so I am explaining you properly. Tunnel FET has 4 terminals. One is gate, drain, source, and body terminal. So out of the 4 terminals, what we can do, the gate, we have oxide layer. So that oxide has some property of a material. All the materials have some dielectric constant. Oxide is an insulator, so it has some constant dielectric constant value. So what we are doing, whenever we want to apply this device as a biosensor, then what we are doing, we are replacing a part of this insulator by the particular biomolecule which we want to sense. Say a biomolecule we are entering in that place, and what we are doing, this biomolecule can say, if we connect with the particular other biomolecules, then this can sense it very easily. That is why we are replacing the high K gate dielectric by a particular material of those dielectric constant. And how we are doing a simulation, because in the simulation we are not
Okay, there was some sort of a technical lag in between, but anyway, continuing with the last part of our discussion with Dr. Bhowmick. This is also fascinating, and I'm sure so many people are going to be benefited with such innovative ideas. Now that brings me to the last question that I have for you. Your message to the aspiring young students, and what routine they must take up in their academics to be able to contribute to India's vision of research and innovation.
Yes, already I have told you about the biosensor, so I'm continuing with that. So what we are doing, we are replacing a part of the oxide, the biomolecules. Then how we measure, then what, this device has some current value. Okay, whenever we are not introducing the biomolecules, then the device is giving some current. And whenever we are introducing biomolecule, then also the device is giving some current. So we are getting the 2 current values. Okay, so now the sensitivity of the sensor, because sensitivity is a major parameter by which we can measure the sensor, how the sensor is working. So whenever we measure the current in under 2 conditions, one condition I already told you, whenever there is gate oxide material is present, whenever there is insulator is present only, and the other case is that whenever there is biomolecules are introduced. So in 2 cases, we can take the current and we can take the ratio. And this ratio gives us the sensitivity of the particular sensor. Biomolecules I am entering, the way of entering biomolecules is very different types are there. Sometimes fully filled biomolecules, partially filled, convex shape, concave shape, different types of introduce of the biomolecules we are analyzing. How biomolecules are entering that area, how they are distributed actually. On the distribution of biomolecules also, current is dependent. If current is dependent means the sensitive parameter is also varying. So these are I am doing, and another thing is that I am doing the application of the various devices in various analog circuits, in various digital application sites. That is also my students are doing. I'm also doing, because now recently I am guiding 7 PhD scholars. 4 are already got awarded, and one has submitted her thesis. So they are all working in the related area.
Okay, so I mean, again, we have faced a little bit of technical glitch. That, as it is, brings me to the last part of my discussion with you. So what is your message to the young aspiring students, and how should they carry on their work in the region and in the, contribute to India's vision of research and innovation?
Yes, students should be interested Those sometimes we are giving in, we are praising our students that you study, study and study, theoretical study. You earn marks. That is actually not important. Whenever an engineer is coming with a lot of marks, but they do not know any practical application, then what is the use of it? So I say that those who are interested in practical studies, we should not pressurize them for getting marks only. They should do their what they want to make. They want to make new circuits. They want to make some projects. So we should encourage them. So we have already started in our four-year BTech course. We have one project in the end semester. In addition to that, I have proposed once to our director, sir, that, sir, please provide them some extra reward, those who are doing some extra work. That is why some students have come from various departments, and nowadays they are doing some extra projects in which they are interested. Some students are very much innovative. What they want to innovate something by themselves. Say, I can, as for example, I can say about a mechanical student. He has developed a new type of cycle. So where he has given various wheels and for competition, he can apply that. So, and some of the students are developing various image processing techniques also, by which we can see various image processing techniques by which we can improve the satellite communication. These things they are doing. So my message is that those who are interested in research, please do the research. Do not go for earning money. Do not go for always academic study. So all of you should do some work that should motivate your juniors, that should motivate your teachers also. Then teachers will automatically come and they will help you if the students are interested. And our local people also, those who want to work, they can come to us. Sometimes we are floating some work. Sometimes some teachers are from our locality. They can also help our local people. They're regarding learning some softwares. Say in summer vacation, NIT Silchar is providing some facility to the local people that they can learn some softwares. They can learn some hardwares also. Like that, some summer training is also considered by our institute. So my message is that all of you should do whatever you like. It is not that under pressurized condition you have to do all the work. You have to do whatever work you like. That is my message to all the young generation of this Northeast and of my local area.
Brilliant, Dr. Bhowmick. That was such a enlightening session with you. On behalf of Atheneum, I thank you so much for making up the time and coming here on this platform and discussing your research and innovation so candidly in such lucid words that all of us could understand. Thank you so much. And on that note, I would congratulate you on all the work that you are doing, and I wish you and your students all the best. And this is such a great thing that you've said, that this relationship, this teacher-student relationship is codependent. If the teacher does something which is excellent, then the teacher-student gets motivated, and if the student does something extraordinary, the teacher gets motivated. This is a brilliant thing. This is a brilliant takeaway. Thank you so much. And on that note, I would end the meeting and hope to associate with you sometime very soon. Thank you.
Okay. Thank you very much for a nice session. You have asked me questions, but I'm very happy that I answered. I do not know whether I have answered up to the mark or not, but people should say whatever I have told, whether it is really useful to the youngsters or not.
I'm sure it will be. I'm sure. Thank you. Thank you, Brinda.
Okay, thank you.